This side here. Hi, everyone. Welcome to the future of web development with ASP.NET Core and Blazor. There's my slides. There we go. I'm Daniel Roth. I'm the product manager for ASP.NET Core and Blazor on the .NET team. And I'm thrilled to be back here at Trailblazer. In this session, we're going to take a look at all the new features and improvements coming to ASP.NET Core in .NET 10, the next major release of the .NET platform. And I'll specifically, of course, focus on the new features in Blazor for front-end web development. Now, ASP.NET Core is a complete modern web framework that comes included with the .NET platform. It provides everything you really need to build high-performance, secure, and scalable web apps, including APIs, microservices, and web UI. It includes an array of web development technologies, including, of course, Blazor for building interactive web UIs using C#, minimal APIs for building lightweight HTTP APIs with minimal code, SignalR for real-time web communication, gRPC for high-performance remote procedure calls, and then lots of built-in and custom middleware for all your request handling needs like authentication, routing, caching, and so on. And then Kestrel, our industry-leading high-performance web server. So it's really a complete package. Blazor is just one piece of this broader offering for handling all of your web development needs. And today, ASP.NET Core is used by over 2 million developers every month. And that number just continues to grow. ASP.NET Core powers some of the largest services in the world, like Microsoft 365, Bing, Teams, Microsoft Copilot, Xbox, and most of our Azure services. These are critical, high-demand applications that millions of people rely on every day. And one of the reasons why Microsoft uses ASP.NET Core is its industry-leading performance. According to some of the latest Tech and Power Fortunes benchmarks, ASP.NET Core is over 3 times faster than Express.js, over 5 times faster than Go when using the popular Gin framework. And with each .NET release, ASP.NET Core just keeps getting faster. So this is a mature and robust web framework that provides a solid foundation for today's cloud and AI applications. ASP.NET Core actually integrates seamlessly with rich .NET platform support for building AI-powered apps. The Microsoft Extensions AI library provides foundational primitives and abstractions for using generative AI. The evaluations library helps you test the quality and safety of your AI apps. Vector data enables integrating with popular vector databases for semantic search and embeddings. We have pre-built AI project templates based on Blazor that help you get started quickly building rich chat interfaces. The C# Model Context Protocol SDK, or MCP SDK, helps you extend AI apps with new tools and data. And then finally, Semantic Kernel adds support for building and orchestrating multi-agent workflows that can handle complex processes. You can learn all about building AI-powered apps with .NET and ASP.NET Core at .NET/AI. Of course, ASP.NET Core developers everywhere are also falling in love with .NET Aspire, which we just heard all about from Maddie in the previous session, which was great. If you missed that one, definitely go and check it out. But just briefly, .NET Aspire is a great way to integrate both AI and cloud services into your ASP.NET Core apps. It makes building, testing, and deploying cloud-native apps really easy. You can add .NET Aspire to any ASP.NET Core app using pre-built templates and tooling. Adding .NET Aspire will light up features like OpenTelemetry, health checks, HTTPS, resiliency, so your projects always follow cloud best practices. You can then run and debug your entire app locally with design time app orchestration and service discovery. You can use .NET Aspire integration packages to quickly connect with services like Redis and PostgreSQL and AI services. You get instant access to logs, traces, and metrics with the .NET Aspire dashboard, the developer dashboard, and then you can deploy to any cloud you want or any hosting environment using flexible deployment configurations. Honestly, if you haven't tried out .NET Aspire yet, you should. You can do so by going to .NET/Aspire. Also, for practical guidance on how to add Aspire to existing apps, be sure to check out the Aspire team's new Aspire Fridays live stream, where they're taking real-world ASP.NET Core apps and adding Aspire to them. They're a lot of fun to watch, and I know I've learned quite a bit in watching those streams. They're pretty great. Okay, so what's next for ASP.NET Core? We're already hard at work on .NET 10, the next major release of the .NET platform. In .NET 10, we're focusing on 4 key areas for ASP.NET Core. First is easier to create secure apps. Security is, of course, more important than ever before. At Microsoft, we've been investing in our own security through the Secure Future initiative. We want to make sure that you can more easily build secure apps too. App observability and diagnostics. We're adding more logging, metrics, and tracing to ASP.NET Core so you can easily monitor and troubleshoot your apps. Targeted performance improvements. We continue to optimize ASP.NET Core so it loads faster, handles more throughput, and uses less memory. And then addressing top pain points and gaps. We're really trying to take the time this release to address many long-standing issues and feature gaps so that development with ASP.NET Core is a delightful experience. So let's take a look at each of these areas in more detail. So first, in .NET 10, we want to make it easier for you to build secure web apps with ASP.NET Core. To do that, we're adding support for the latest security standards and best practices. Specifically, we're adding support for WebAuthn and Passkey authentication to enable support for passwordless authentication with ASP.NET Core identity. And I'll talk more about what passkeys are in just a moment. We're also making it easier to set up authentication by expanding our support for scaffolding authentication into existing apps and improving also our documentation for identity and authentication in ASP.NET Core. Okay, so what are passkeys? Well, passkeys are cryptographic credentials that replace traditional passwords or augment traditional passwords as well. The great thing about passkeys is they're phishing resistant, they're easy to use, and they're secure by design. Passkey consists of a public-private key pair that's scoped to a specific account and origin. The private key is typically stored in an authenticator app, and then the authenticator handles verifying the user identity before allowing authentication with a stored passkey. So in .NET 10, we're adding built-in support for passkeys to ASP.NET Core Identity. We're taking a lot of inspiration from the open source FIDO2 netlib library, and we've actually been working really closely with that project's maintainers. They've been tremendously helpful, and we really appreciate their collaboration. We plan to support both resident and non-resident keys, but we don't plan to support attestation for the authenticator in .NET 10. That's something on our backlog that we'll consider for a future release. We're updating both the Blazor project templates and the Blazor identity scaffolder to add support for passkeys. And for existing projects that already use ASP.NET Core Identity, we will provide guidance on how you or GitHub Copilot can manually add passkey support. All right, so let me show you real quick, what does the new passkey support look like? I've actually got a new build of .NET 10 installed for .NET 10 Preview 6, which should be available here in just a couple weeks. So some of the things I'm going to show you are brand new, hot off the press. Let's go ahead and create a new Blazor web app. I'm going to, I don't know, what do we call this? Let's call this Passkeys Demo. That sounds good. And we'll use .NET 10 Preview. I'm going to set the authentication type to individual accounts, so that will set up ASP.NET Core Identity. And included in that template now is support for passkeys. We'll leave the other defaults, and we'll go ahead and create that. All right, great. So now let's go ahead and get this running and see what the app looks like. That's probably going to pop up over here on my other monitor once that builds. Build, run. There we go. Okay. So now that the app is firing up, all right, just give it a second. The machine is obviously crunching hard to video stream. Okay, there we go. So here's the running app. All right, and so you can see we've got some UI for logging in and registering new users. Let's register a new user. And initially, I'm going to set myself up with a password. We don't support passwordless account creation yet. That's something we do have on our backlog as well to consider. For now, let's go ahead and register that. Now, because I just created this project, the database hasn't been set up with the identity schema yet. So I should get a little error here saying, hey, the database isn't ready. Do you want me to run the Entity Framework course migrations to set that up? There we go. So then we should just be able to refresh. And now we're good. Okay, let's confirm our account. And then now we should be able to log in. And you can already see that there's that initial UI right there for logging with the passkey. I haven't set up my passkey yet though, so let's do that first. So I'm going to go to my account profile, and you can see there's a new tab here for passkeys, and let's add a passkey. Okay, so here Windows is going to verify that it's really me by asking me for my PIN. Oh, what did I do wrong? Add a new passkey. I think I accidentally hit the cancel button. Okay, so now we've created a new passkey, and I should be able to give it a name. Let's call it Windows. Okay, cool. So we've got our passkey now set up in our account. We have the option of also adding additional passkeys. Like if we want to add a passkey based on our mobile device or a security key, we could do that too. But I'm just going to leave it with the one that I've got currently configured. Okay, so let's go ahead and log out. And now we should be able to log in with our passkey. And we get prompted by Windows to select which passkey we want to use for this particular host. It's going to verify that we really are who we say we are. And there we go. We're logged back in. Okay, so that's the new passkey support. It's just included in the default Blazor Identity UI. It's in the templates, and we're going to be adding it to the Blazor Identity scaffolder as well. Okay, now speaking of scaffolding, to make it easier to set up authentication in ASP.NET Core apps, we're working on a new set of authentication scaffolders based on the new .NET Scaffold tool. The nice thing about scaffolding is you don't need to create a new project to set up auth. You'll just be able to scaffold auth support into your existing projects, and it's a cross-platform tool. The .NET Scaffold tool already supports scaffolding ASP.NET Core Identity into existing apps with a convenient interactive command line flow. In .NET 10, we plan to add authentication scaffolders for setting up authentication with Entra ID. That's something I know we've been missing for a while on the Blazor web app template. We'll have scaffolding for that, and then we will integrate that into Visual Studio so that you can use that scaffolder from Visual Studio as well. We also are planning to add a scaffolder for setting up the code for the ASP.NET Core Identity endpoints. These are programmatic endpoints that give you programmatic access to the ASP.NET Core Identity system. And then also for a scaffolder for adding authentication to Blazor hybrid apps. Now, these scaffolders are still in development, but we hope to make them available later this year. Okay, so that's security. Next, let's take a look at app observability and diagnostics. So in .NET 10, we want to make it easier to monitor and diagnose issues in your ASP.NET Core apps. We're adding a bunch of additional metrics for things like Kestrel's memory pool for authentication and authorization, and of course, also for Blazor. We're also adding activities to Blazor Server to trace Blazor app level actions, things like app navigations and UI events. So you can see that in your in the distributed tracing tooling. We're also adding diagnostic tools for Blazor WebAssembly apps, so you can do things like performance profiles and memory dumps. And we're also working with our friends on the identity model team to integrate their logs into ASP.NET Core logging so that you can see all those logs in one place. Okay, so let's take a look at some of the new metrics, traces, and diagnostics. Let me go back to Studio. All right. So here, what I'm going to do is let's use this app to look at some of the new metrics. And one of the easiest ways to see your metrics and your traces is using .NET Aspire. So let's go ahead and add .NET Aspire to this Blazor app. It's super easy. We can just right-click and say Add .NET Aspire Orchestrator Support, and that will add the needful artifacts normally. Now, my project is it's a new .NET 10 project, and Aspire has not actually released .NET 10 support yet. .NET 10 is still in preview. So if I actually try to add .NET Aspire Orchestrator support right now, then I'll get some errors saying, hey, I can't find templates for a .NET 10 project using .NET Aspire. So in order to just work around that for now, .NET 10 support from Aspire is coming. But as a quick workaround, I'm just going to lie to Aspire and tell it, oh, no, this is a .NET 9 project. It's totally fine. And because it's very backwards compatible, it actually works just fine. So we'll go ahead and add .NET Aspire. You can see that this is going to add a couple of additional projects to my solution with some Aspire goodies. Let me switch this back to .NET 10 now. Okay, great. So first of all, we can see over here that we now have this app host project. And this is the project that's going to model our entire solution. in this app post.cs file, this is where you like all the different processes that make up your app. They all get modeled here and orchestrated. We only have one app in this solution currently, just my Blazor app. But you can imagine you have like minimal APIs or backend microservices and so on. We also get this service defaults project, and this has just some helper code that sets up all sorts of things that ASP.NET Core has always supported, but always was a bit tedious to wire up. Things like open telemetry and health checks and service discovery and resiliency and so forth. Aspire just gives you the code to set it all up for you, which is fantastic. Now I want to see the new metrics that we just added in .NET 10. If we go looking in this helper code, there is this configure open telemetry method that sets up things like the basic ASP.NET Core metrics and the basic ASP.NET Core traces. But I want to see the new metrics and tracing, so I need to actually add those. So I'm just going to add a little bit of code here and replace this line with some stuff. And you can see I'm adding, a whole bunch of additional meters and also some additional trace sources so that we can see those new capabilities in .NET 10. Okay, so let's go ahead and run this and see if we can see the new metrics. Now, because I'm now running an Aspire app, you can see that the startup project is my app host project. So that's what's actually being run right now. And that will then take care of running all of the different parts of my application. And also, hopefully, display, once it gets going, the awesome .NET Aspire developer dashboard. There it is. All right, do I have another app running still? No, we're good. Okay, so here's the .NET Aspire developer dashboard. This is like this one-stop shop for all of your console logs, your structured logs, traces. Let's get all these things going. Metrics. It's all here at your fingertips when you're doing development, which is super duper nice. You can also see all the different parts of your app. Like here's my Blazor app. I'll go ahead and run that so we can see that. Let's do a few things. Let's log in again. So we cause some data to happen. Set up my pin. Looks good. Let's go to the counter and click on the counter a bunch of times. So we got some Blazor stuff going. Okay, great. So now let's take a look at what metrics we now have. Now all these metrics up here at the top, like all these guys, these are all new. So we've got metrics now for authentication. Like we can see the authentication duration and how many sign-ins that we've got going, how many sign-outs. We can see all of the authorization attempts that have happened in our app. And then we've got a whole bunch of Blazor-specific metrics, which are super nice. Like we have this new ASP.NET Core Components navigation metric. This is showing me all of the page navigations that have happened. Let's do a couple more. And then if we have these filters over here where we can look at the specific route, and we could see how many times have someone visited the counter page. And apparently it's 3, or how many times have people gone to the login page, 2, and so forth. And we can also filter by specific routable components. So that's pretty nice. Let's go ahead and remove all those filters. We also can see metrics for the various event handlers that have fired in our app. We can filter by specific event types, like on click or on submit in this case. And we can also filter on specific event handlers, like our increment count event handler for the counter, and submitting the various forms. So got all this data now right at our fingertips. These lifecycle metrics are a little bit more low level, but they like this render diff metric lets you get data on how performantly your components are rendering. And the update parameters gives you data on how long it's taking your components to process the incoming parameter data. So if your components are operating a little bit slowly, you can dig in here to see where that's happening. And then we've also got Blazor Server specific metrics, like we can see how many active circuits we've currently got in this app. Right now we've just got one because we only have one tab open with a counter. But if we duplicate that tab, now we should see, it jumps up to 2 active circuits. If we close one of these, we should be able to see circuit duration data. And then we also have this connected circuits metric. Unfortunately, there's a bug in Preview 6 where this is not quite working right, but this metric should let you see how many of your circuits actually have an active network connection as opposed to being in a disconnected state. Like how many circuits are just sort of sitting around waiting to see if the user is going to reconnect. Okay, so that's coming hopefully in the next preview release after Preview 6 in about a month. All right, so those are all the new metrics for auth, authorization, and Blazor. We also have new traces. So here on the traces tab, let's filter actually to just the Blazor traces. I'm going to select source, contains, Microsoft ASP.NET Core Components, which is the Blazor namespace. We'll apply that filter. And now we can see a whole bunch of top-level Blazor traces for all the things that are happening in my Blazor app. Like, let's see, we can see that, we created we browsed to /counter right here. So we're seeing page navigations. We can see a circuit was created. We can see all the on-click events that occurred within that circuit. If we dig into one of these traces, like this circuit creation trace, and look at some of the metadata associated with it, we can see other useful stuff like all the related events are linked up to this trace. We can see the parent call to the actual underlying Blazor Server component hub, SignalR component hub to actually start the circuit. So all your traces are linked up so you can correlate them. So that's the new Blazor Server tracing support. You get some really nice views of what's going on in your Blazor Server apps now, instead of just seeing one big, giant, long WebSocket connection. Now, what about this is mostly for what we're seeing here for server-based Blazor apps. What about WebAssembly? What about your Blazor WebAssembly apps? We don't currently actually have a great way yet to pump telemetry data from Blazor WebAssembly into like the Aspire dashboard. That's something that we still want to do and that we're thinking about. But we are giving you a bunch of diagnostic tools in .NET 10 to help you figure out what's going on in your Blazor WebAssembly apps. So let me switch to that. Let's close down this application. I'm actually going to switch now to a Blazor WebAssembly app. Let's go to this Blazor browser profiling application. So this app is a Blazor web app where I've turned on interactive WebAssembly rendering. And I've also flipped some switches in the project file so that we can do in-browser performance profiling, like get some performance data while the app is running in the browser using the browser dev tools. So I think here we're actually setting up the browser WASM profiler and then configuring the runtime with a bunch of switches that it needs to be able to collect this data. Okay, so let's go ahead and run this app. Let's see. There it goes. Okay, it's popped over here on my other screen. Now, if we go to the counter page and just make sure it's loading up. Okay, good. And then if we go to the browser dev tools, let's go to the performance tab and let's just start recording. Let's record some performance data for our app. And I'll click on the counter a bunch of time to generate some data. We'll go ahead and stop. And then now what we get, you can see there's this new timings tab that Blazor has added to the dev tools. And if we expand that, we get all this timing information from the .NET WebAssembly runtime. These flame charts of what's happening, where time is being spent in the execution of our app. And you can kind of see there's all these various spikes. Each of these spikes probably represents a particular counter click on the runtime, generating a bunch of performance data. So this is a way you can dig into your Blazor WebAssembly apps, the performance, and sort of trace down what's going on using the browser dev tools. We're also giving you a way that you can extract diagnostic information from the Blazor WebAssembly app in the browser, so you could analyze it in Visual Studio. To do that requires a slightly different runtime setup. So let me switch apps one more time. So let's go to this Blazor Diagnostics app, and I'll go ahead and get that running while I show you the code. So here in the client project, different set of properties, and you can see we're doing things like setting up metrics and enabling event sources or event pipes, and general diagnostic support in the runtime, so that we can collect a bunch of rich diagnostic information. And currently, the way you do this is we provided some JavaScript APIs that you can use to extract the diagnostic data. So again, let's go to the counter page. This will load up the WebAssembly runtime. And then let's go this time to the browser dev console. And what I'm going to do is, let's see, what's the, okay, yeah, so let's collect a CPU sample first, collect some performance profiling data. So here we've got this, you get the .NET runtime, you call collect CPU samples, and we're going to do it for 5 seconds. Okay, so let's go ahead and run that. And then I'll mash on the counter button again to just make sure we get some data to show. And then this, you can see it downloaded a net trace file that we can now open up in Visual Studio and analyze. So if we go back to VS, let's go into my downloads folder and open up that net trace file. And you can see it loads up a bunch of performance data. Awesome. Okay, so that's how you can get like CPU samples. There's other things you can do too. Like let's say we want to get metrics, like collect metrics from the Blazor WebAssembly app. We can do that using this collect metrics API. Again, we're doing it just for 5 seconds. I'll mash on the counter button. That should give us another net trace file. There we go. This one is 9658. So let's go back to Visual Studio. And let's open up that one, 9658. There we go. So now we're seeing all the metric counter data in that net trace file. And then the last thing we can do is also collect memory information, like collect a GC dump. Let's go back to the app. And we'll call, instead of the other two methods, this collect GC dump method. And there's no duration for this. It's just going to dump the memory. And it's again going to give us a net trace file. To load this in Visual Studio, that's honestly not what I really want. What I really want is a GC dump file. So what I'm going to do is I'm going to take that file and use a .NET SDK tool called GC dump, which you can just install on the command line. And I'm going to convert that file. Which number is it? It's 8407. So trace 8407. And that will just turn that net trace file into a GC dump file so we can more easily load it in NVS and analyze it. So now if we open up our GC dump file that we just converted, we should see a whole bunch of memory information. Like we can filter in here for our counter component. And yeah, there's our Blazor counter. Okay, so that's a bunch of ways you can get diagnostic information also out of your Blazor WebAssembly apps too. Cool. All right, next, performance. To ensure that .NET 10 is the fastest release of ASP.NET Core yet, we're doing a bunch of performance work. We're, first of all, updating Kestrel's memory pool so that it can now release memory. I'll talk more about that in just a second, but this enables more efficient memory use on the server. We're doing work to improve JSON deserialization performance for APIs in ASP.NET Core by using the new pipe reader support in system text JSON. We've done a bunch of perf work on anti-forgery in .NET 10, and we're also adding some really nice optimizations to speed up the startup time of Blazor WebAssembly apps. Now, most ASP.NET Core apps run on the Kestrel HP server, including Blazor apps. Kestrel will pool memory to avoid allocations, and it grows its memory pool as needed to handle increased load. Currently, in the existing .NET stable releases, it doesn't ever release that memory, even if traffic later drops. And this became an issue actually for one of our internal Microsoft partner teams, Azure App Service. They use Kestrel to handle literally billions of requests per day on their front end. And after a traffic spike, they would see a spike in memory usage from Kestrel that would then stay at a high watermark. So we worked with them on improving that. We tested a few different approaches with them in their production environment. The charts on the left show the new behavior. Unused memory is now evicted from the pool, and total memory is now decreases, which is great. This is great for Azure App Service, but it's also great for all of you and all of us. These improvements are now built into the framework, into .NET 10, and they will ship shortly with .NET 10 Preview 6. I think this is a really great example of how Microsoft's experience using ASP.NET Core at hyperscale results in platform benefits for everyone. You get better scaling, lower idle costs, and smarter resource use thanks to these investments. Like I said, we're also making improvements to startup performance in Blazor WebAssembly apps. What we've done in 10 is the Blazor framework scripts are now provided as static web assets. You may remember in .NET 9, we did a bunch of work in ASP.NET Core to improve our static web assets support in the framework by adding support for pre-compression of those files, fingerprinting, and aggressive caching. Many of the Blazor framework files were not actually those served as static web assets. They were kind of like assembly resources, kind of tacked on in exotic ways. In .NET 10, that's all been cleaned up, and they're now all just normal static web assets, so they get all of those optimizations: fingerprinting, pre-compression, and caching. We're also adding support for preloading these framework files, so you don't have to wait for a cascade of requests before your app loads. Okay, let me show you some of these Blazor WebAssembly startup improvements. All right, let's go to my Blazor WebAssembly startup app. Okay, so this is a Blazor web app where I have interactive WebAssembly rendering enabled. And let's just go ahead and run it and see what's happening on the wire when this app actually loads. Okay, so let's go to the counter page. And what I'm going to do is we'll just go ahead and open this up in the network tab. Let's refresh so we can see all the things that are being downloaded. And this will look enormous during development, and that's because we don't do any of the trimming optimizations during development. A lot of the pre-compression stuff and caching stuff also is only done on publish. But there's the new improvements in 10 we can still see here even in the development time. So first of all, notice that our framework scripts like .NET.js, Blazor Web.js, .NET Runtime.js, .NET Native.js, these all now are fingerprinted static web assets. So they have a unique hash based on their content. So if the file changes, then the file name will also change. That means they can be aggressively cached. It means you'll now avoid any chances of accidentally like loading the wrong version of Blazor WebAssembly with your app because of caching issues. So much more performant handling of these files. If we go poking in here, we can also look at on the counter page that we downloaded. You can see up at the top that we've added a preload link to preload .NET.js because we know we're going to need to load the .NET WebAssembly runtime on this page. So might as well request it up front. That makes helps the runtime start up faster. Where does that link come from? Previously, by the way, if you've seen been following along with like the Blazor community stand-ups, we used to do this with a link header. We decided to switch to a link tag even for the server-hosted scenarios, just because it proved a little easier to make correct. So we now have this link preload component that we've added to the template, and you can add to your apps that will generate the link tags that will preload the runtime assets. So that's where that's coming from. You may also notice that if we look at .NET.js, all of this metadata here that's being packaged in this file, this used to be packaged in a different file, in a file called blazor.boot.json, which was just a JSON file. We've now moved it into that content into .NET.js. This is kind of like a manifest of all the assets that make up your app. The nice thing about moving it into .NET.js is it can now be fingerprinted along with that file, and all the other optimizations now apply. So it will load faster. Also, we have started, you may see here that we're starting packaging the Blazor environment data into this file as part of the file, which gets included as part of your build. In the past, in order to flow the environment for a Blazor WebAssembly app to the client, you had to set up a header, and that was a bit clunky in certain hosting environments. Now it just will happen as part of your build, which should make flowing the environment also much more robust. Now, this is a server-based application, so a lot of the optimizations you're seeing here are being handled by the server. You may wonder, like, well, what about my standalone Blazor WebAssembly apps that I'm just like hosting on GitHub pages or whatever? Well, these optimizations apply there too, though it's done slightly differently. So if we look at a standalone Blazor WebAssembly app, what we do is we put a bunch of placeholders in your index.html file, and then on build, we will replace those with the optimized patterns. So like here, you can see we're in the template now. We add a link preload placeholder tag, and that on build will get replaced. Similarly, we add like a script import map that will get replaced with all the import maps for all your JavaScript files. And then we also have a placeholder for the fingerprint for the blazor.webassembly.js file. And all these things at build will get updated thanks to this property that you can now add in .NET 10 in your project file. So override HTML asset placeholders. But the end result is exactly the same. All the files get fingerprinted, pre-compressed, cached, and optimized in those ways. So your apps load quicker with fewer cascading requests and more efficiently. All right, cool. How are we doing on time? Okay, 12:35. All right, backend. So I mean, ASP.NET Core obviously doesn't just do Blazor. It has a whole industry-leading support for building backend services, and we are doing a bunch of work in .NET 10 to address top backend pain points and feature requests. For minimal APIs, we're addressing some key feature asks, and we're really trying to invest in minimal APIs as our recommended and preferred way for building fast, lightweight HTTP endpoints. What we've done is we've added minimal API validation support so that you can ensure your API endpoints receive valid input. We've also added support to minimal APIs for server-sent events, which allows you to push updates from the server to the client in real time from your API endpoints, which is a popular pattern like for AI-based applications. We also continue to invest in our OpenAPI support. We're adding support for the latest OpenAPI spec version, which is 3.1. We added support for generating OpenAPI descriptions from your XML doc comments. And for all you YAML fans out there, we also added support for generating the OpenAPI document in YAML format. Other pain points that we're addressing, we've added support for JSON patch, now using system text JSON instead of Newtonsoft.json, which we've had for a while, but kind of was at odds with the modern approach for handling JSON in the .NET platform. We've also are doing work to generate correct unauthorized responses for APIs when they're hosted in a web app. Like in a web app, you often, when someone's unauthorized, you often want to redirect them to the login page. But if you have an API, you typically want to return a proper 403 like unauthorized response to the client. That's a bit hard to do still in ASP.NET Core. We're going to do some work intent to make that more straightforward. Now, this is not a back-end presentation. This is a Blazor conference, so focused on front end. But I do want to show you one back-end feature because it also relates to a new Blazor improvement. So let me show you this. I'm going to open up this. It's actually a Blazor app, this Blazor validation project. And I want to show you the minimal API validation support. So here in Program CS, down at the bottom, you can see I've got a minimal API endpoint, map post, that takes an order model. And if we go look at that order model, we can see that this order model is it's got a nested structure. We've got, a customer details. We've got order items. And the customer details, I think, also has like an address. There's an address down here. So, rich object graph for the model. And it's all decorated with data annotations for adding validation rules. Things that are required, string lengths, making sure that the email address is a proper email address, and so on. Okay. So what I can now do, I've set up an HTTP file so I can send a request to that endpoint. Let's go ahead and run the app so we have an endpoint to actually hit. Okay, great. And then what I'm going to do is go ahead and send. This request should be fully valid. Like I think all this data is meets all the validation rules. And yeah, we got a 200K response. Looks good. But now if we down the object graph hierarchy, if we add a validation error, let's change the quantity here to 200. I think there's a validation rule that it has to be less than 100. Or if I mess up the email address, and let's now resend the request. There we go. Okay, so now we're getting validation being enforced, and we can see yep, that's not an invalid. That is an invalid email address, and the order was greater than 100. So minimal API validation is working. But what's really cool is that the same infrastructure we're using for minimal API validation, it's generic, and so we're also now using it for Blazor. So if we look over, let me undo this. There we go. Okay, if we go to the home page of this Blazor app, you can see that I've set up an edit form, and it's using our normal built-in data annotations validator. But because we've enabled validation support in Program CS, there's one little API call that you need to add here, which is right there. Yeah, so you just say services.add validation. Because we've done that, this data annotations validator will now validate the entire object graph. Before, it would only do one layer deep, which is a little frustrating. And we had some early, I think, preview packages that did object graph validation a while back, but we never really shipped a stable version of them. In .NET 10, that functionality is now built in using the same infrastructure that we're using for validation in minimal APIs. And you can see we've got a great big old form here that's displaying all the validation messages for the various parts of our form. Here's what it looks like in the actual app. So if I just go ahead and try to submit this form without putting anything in, then all the validation errors kick in, including things in the child objects. And as we start filling stuff out, let's say this is a pizza's order, this is for me. Let's say I put my email address here, but I mistype it. Invalid email address. Let's make it right. Now it's good. Send it to Microsoft. What should be in my piece order? Let's say Hawaiian. No pineapple. And that looks good. And if we try to say I want 200 of those, it's nope, it has to be 100. So this is all working great. Okay, so Blazor in .NET 10, you get full object graph validation support out of the box using the built-in data annotations validator. Pretty nice. Let's shut that down. There we go. Okay. Ooh. So that's back end. What about, of course, the front end? So for front end development with ASP.NET Core, how much time we got? 19 minutes. We're similarly looking to address top developer pain points and fill existing feature gaps. Our front end investment focus is, of course, on Blazor, our most comprehensive and flexible web UI framework. Earlier frameworks in ASP.NET Core, like MVC and Razor Pages, are, of course, still fully supported, as is building your front end using like JavaScript frameworks. But Blazor is our recommended .NET web UI offering, and it's where we're focusing our time and energy. In .NET 10, we're particularly focused on improvements for server-side rendering, which is currently actually our most popular Blazor hosting model. But we have some nice improvements for Blazor WebAssembly too, as you've seen previously. So things that we're adding support for state persistence in .NET 10 to address many of the common pain points with the stateful nature of Blazor Server apps. And I'll talk more about that in a minute. We're doing work to make Blazor behave more consistently across its various render modes, like when doing page navigations and how it handles NotFound responses. We're fixing some common problems with scroll position handling and doing enhanced navigations. We're adding some commonly requested features for our QuickGrid data grid component. We're smoothing out our JavaScript interop story, and we're also making it easier to do automated browser testing for Blazor apps with the web application factory helper type using Kestrel, using a real server. Now, one of the biggest investments we're doing for Blazor in 10 is Blazor server state persistence. Blazor actually already has some support for persisting component state during pre-rendering using the existing persistent component state service. This service allows you to reuse any state that you use for pre-rendering your components so that it can be used later when the component renders interactively. Now, using the persistent component state API is, it's okay. It's a bit tedious. So in .NET 10, we're introducing a simpler declarative model. You can just add an attribute to your component to say what state you want persisted, and you're pretty much done. Now, we also want to improve the resiliency of Blazor Server apps by giving you the option to persist circuit state when a client gets disconnected. In Blazor Server apps, when a user disconnects for an extended period of time, like this can happen when if their browser tab goes into the background and then goes to sleep, and then the browser decides to kill off all the network connections, or maybe you're on a mobile device and you swipe away from the browser, and so the mobile device, kills all the network connections and puts the browser to sleep to save power and free up resources. What happens then is the server sees that the connection is dropped, and then it has to decide what to do. And today, Blazor will hold on to your circuit state for a little while to see if the user is going to reconnect. But after some time, by default 3 minutes, it will say, I guess that user's gone, and then it will evict the circuit to free up those resources. If the user then comes back later and tries to reconnect and use the app, then their state is lost. So in 10, what we're doing is Blazor server apps will be able to automatically persist state of circuits before they're evicted. This means that if a client comes back, reconnects later after a prolonged period of time, the app can restore that state and the user can resume their work uninterrupted. We think this is also going to be useful for improving scalability of Blazor server apps. We're going to give you APIs so that you can decide when you want circuits to be persisted, and then the ability to reload them. So you could have a policy, for example, like if the circuit is idle or the browser isn't even visible, then you can say, you know what, I'm just going to persist and then evict this circuit, and then when the user comes back, I'll restore it later. We don't plan to do this automatically, so this will be a policy that you define, but we'll give you the API so that you can do it yourself. Okay, that's a lot of stuff. Let me go do a quick whirlwind of final Blazor demos of some of these improvements. Let's go back over here to Visual Studio. I'm going to open up this NET 10 project and show you just a couple quick things here. And we'll do a Blazor server persistence demo and then wrap it up. Okay, so here's a simple Blazor app. This one is using QuickGrid to display a list of movies, right? So we got some movies here. Now, one thing that people often want to do with QuickGrid is they like to style the rows of QuickGrid based off of the data for that row. We didn't really have a good way to do that. We do now. I'm just going to switch branches to show this. So we have added a new row class parameter to QuickGrid right here, where you can pass in a delegate to say, given the data for this row, return a CSS class that you want to use. So like here, I'm saying if the release year is older than, or is later than 1999, then it's a new movie. Otherwise, it's an old movie. And then I have some styles set up in the app to style the rows accordingly. So if we go ahead and hot reload that. Oh, did I not save? Yeah, there we go. We update that. I'm just going to, not sure why hot reload didn't do that. Probably because I decided to switch branches. There we go. Okay, so now my row class is being applied dynamically for each row based off of the data there. Another common scenario we heard from people is like, with QuickGrid, you can set up these little widgets on your columns. These are called column options. Like here, I have a little title filter. If I want to look for movies based on rings, I can apply a filter. But notice that when I apply the filter, the column options UI stays. Like it doesn't go away. I have to like click off of it for it to go away. How could I fix that? Well, we've added a new API on column options on QuickGrid, actually, where you can hide the column options. So here, if we look at the code, here's our column options for the title filter. And you can see that we're binding the title filter right here so that we can use it to adjust our iQueryable. But now I've just added this bind after, which says like after the binding's done, grab the QuickGrid and hide the column options once that binding is complete. Like if I hit enter, go ahead and hide the column options. I don't need it anymore. Okay, so if I apply that. Cool. Okay, so now if I say rings and I hit enter, immediately the column options goes away. So you have control over the column options visibility. Let's get this back. A couple other nice little things. Like if I scroll down to the bottom and I click this button up top, let me give yourself a little bit more space so we can see it. If I click this button up top, you can see that it added a query string parameter, but I didn't lose my scroll position now. That's new in .NET Dan. Before it would jump up to the top, which was a little annoying if you were trying to like sort of store state up in the query string. We now have in the default Blazor web app template, we have a better support for not found pages. In fact, we include a notfound.razor page in the template now. And this can be configured on your router. Like you can see here, there's now a new not found page parameter that you can pass to the router to tell it like, hey, this is the page I want you to render if you're going to do a 404. And then we also set up a status code page re-execution to use that page in program CS. So if I browse to foo, then my not found page now will render. We also have APIs where you can trigger that programmatically. Like if I go to back here and let's ask Copilot to add a button that calls nav.notfound, which is a new API that we've added in .NET 10. We should be able to trigger that not found behavior programmatically. Give Copilot a second to think about how to do that. There it goes. Let's see. So I added a method. No, Copilot. I told you I wanted this to be not found. It doesn't know about this API yet, so it struggles a little bit to use the new .NET 10 APIs. All right, so let's go ahead and add that. And so I should be able to. I have to keep it. Yeah, great. So let's go ahead and add that. Okay, so now you can see go to not found. You can see I can just click that and trigger a not found response. And the nice thing about that API and this infrastructure is it works across all the render modes, whether you're doing static server-side rendering, interactive server-side rendering, client WebAssembly rendering, the behavior is consistent. Okay, so that's the new not found support. You'll notice also that we have a new reconnect modal component included in the project templates. This allows you to control the UI that appears when the user gets disconnected. So there was a default UI that we included in the framework, and you could always change it, but now it's just right there at your fingertips. So for example, when rejoining the server, if we feel like we want some more emojis, we can just update this right here. And then if I go ahead and kill the server so that the client gets disconnected, we should have, I forgot to my hot reload tooling decided to break on me. Classic. Hot reload we know is also an area that needs improvement in Blazor. We are working on it. So let me try this one more time. So let me kill the server and we should see, yeah. So now we can customize the reconnection UI. Okay, I've got just a couple more minutes. Last thing I want to show you is the state persistence work. So to do that, let me switch from this project to this pre-rendering project. Okay, so when to sort of motivate the set of problems, and when you have an app that in Blazor loads some state asynchronously, like here you can see we're loading a list of movies by calling get movies async. Blazor will actually like render twice, like it'll render when the task is initialized and then when the task completes, and that allows you to do things like render placeholders while you're loading the movies. Like it might take a long time to get the movies from a database or from an API or whatever. So this gives you an opportunity to insert that UI, those UI placeholders. Now here you can also see that I've enabled streaming rendering. So even when this page is rendering statically, it will render that placeholder and then stream down the actual data content. But it's also interactive. So that means that it has to then re-render again interactively. And there's reasons for that we can't reuse the DOM that was set up during pre-rendering. But currently in Blazor, we have to reestablish the DOM. And so what happens often here when you have state being loaded asynchronously like this is you see like placeholder, then the data. And then you see placeholder and the data again as the component renders twice. So I'll just show this how this looks. Hopefully you'll be able to see it through the live stream. Okay, so if we go here and let's go to the movies page, you see loading and then data. Let me refresh. Loading, data, loading, data. You see that? So it's loading, data. Like you see this flash. So how can we fix that? Like we're fetching the data twice and we've got this flashing UI behavior that's currently happening. Not good. Well, the way you can solve this today in Blazor is using that persistent component state API that I mentioned earlier. So we've got this service that you can add, and then you can use it to reuse the state that you got during pre-rendering and flow it to the interactive rendering, so you don't have to fetch it twice. Okay, and because you then have the initial data already, you don't need to fetch it again asynchronously, and so you avoid that double rendering flash. Now the API is okay. It's not the easiest thing to use. Like you have to like call this try take from JSON to see if the persisted data is already there. If it's already there, you just use it. If it's not already there, then you gotta get it. And then you set up a subscription to persist the data at the right time. And Blazor handles that. When you're persisting pre-rendered state, it'll persist it into the HTML page, like as a comment. And then you of course gotta dispose to clean up that subscription and so on. So not bad. And this works. This works fine. This works with .NET 9. In .NET 10, we're making this simpler so that the code now looks just like this. You just have your property that represents your state, and you can annotate it with supply parameter from persistent component state. We know that's the longest attribute in the world. We actually do plan to rename this to something shorter. For now, that's what the current name is. And then when you're initializing your component, you can just check like, hey, do I already have the state? Like, was it already there? Was it provided from the persistent component state? If not, then let's go get it. Okay, so that's what the code now looks like for dealing with pre-rendering and state persistence. And this will, of course, hopefully work exactly as intended. Let me get this back up, and we now go to that movies page. And if we refresh, we should just see the loading once, and then we see the data. No flash. Awesome. Okay, so that's great. Now, this same infrastructure we can now use for doing things like making Blazor Server apps more resilient and also more scalable. And show you what I mean for that. Let me go back to that passkeys demo that we did at the very beginning, because I'm going to try to use Aspire here to help me show this. So the first thing I want to show is that in .NET 10, Blazor will now automatically persist the states of components before they get evicted if the client gets disconnected. Okay, and so in order to it's a little tricky to demo because you got to like force the disconnection without like losing connection with all of you guys, and you also don't want to sit around and wait for that 3-minute timeout for the Blazor to decide that it no longer needs the circuit. So in order to just show that this is actually happening, I'm going to make a couple of quick changes to the app. First, I'm going to go into my how I'm configuring interactive server rendering, and I'm going to tell it like, hey, don't hold on to any disconnected circuits. Just get rid of them all. So no disconnected circuits allowed in this application. Okay, and so now if I run the app like this, let's see what happens. Go. So if we go here, and now we see our app, let's go and get the actual Blazor app running. And then if we hit the counter a bunch of times, now, so we've got an active circuit. Now what I'm going to do is I want to kill the connection for this circuit. And there's unfortunately not a great way to do that. So I have this little cheeky internal API that you should not use. This is not a public facing API. It's just demoware. But I'm just going to force the connection to close using some JavaScript. Okay. Now watch. Notice our counter is currently at 5. So it killed. Oh, shoot. Hold on. That's a bug. Just ignore that. So counter is currently at 4. I'm going to kill the connection. You notice that the connection went down. Blazor tried to reconnect. Wasn't able to reconnect to its original circuit, so it created a new circuit, and now our counter is lost. This is what often happens to Blazor apps today. Now we can fix this in our counter by going into the code and using that persistent component state logic. So let's go now to our counter, and let's update. Instead of having our count just sitting here as a field, let's have it be persisted. Let me fix up the code, okay, and we'll go ahead and restart this. All right, so now if we go here and we go to the counter, click, 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 click. Let's do our cheeky little demoware call again to kill the connection. Oh, let me refresh one more time so I avoid that little preview bug. All right, so we're at 4. Close the connection. That bug. There. Okay. So I don't know if you saw that. So we force close the connection. There was a blip as the app got disconnected. It tried to reconnect. And because the state was now persisted, we were able to recover it. Okay, so like if you swipe away on your phone, the circuit goes away, the user comes back, they can re-establish their state. So it makes the app more resilient. The last cool thing to show is that it also makes it easier to scale. So what I'm going to do is add one more change to this Blazor app. I'm going to go into the app.razor file and add a little script. And this script will use a couple of new APIs, which are APIs you can use to pause the circuit and also resume the circuit. So what this is doing is saying, if the browser is currently hidden, we don't need the circuit. Might as well pause it, persist it, and free up those server resources. If the browser is visible, then resume. Like we want the circuit to reestablish the circuit with the persisted state. Okay. So now if we run this is really cool. So now let me close all these guys. Let's get actually a couple of circuits going. So counter, give them some clicks. So we got 4, 3, whatever, doesn't really matter. And let's kind of snap these guys around. That one there. I need these to be visible for the time being. And then where's my dashboard? Okay, so remember the metrics that we looked at before. Let's look at the number of active circuits that we've got. So where's circuits? Right here, active circuits. So it says it currently that we have 2 active circuits. You see that? I'm going to use a table view because it's a little more responsive. But if I hide one of these browsers, I'm not closing it. I'm just hiding it. Notice that the number of circuits just went down. So we just freed up those server resources. But if I then bring it back, notice that the count is still there. We saved that circuit. We brought it back. And now we have the circuit again. So now we're back up to 2 circuits. You know, if I hide all these browsers, we can free up all those server resources. We should see this click down to 0. Yep, it does. And then we can bring them back. And now we've got our state back again. Okay, so that's Blazor state persistence in .NET 10. Super cool, super excited about it. Okay, that's all the stuff that we're doing in .NET 10. I know I've eaten up all my Q&A time. I really apologize for that. Here's a summary of everything that we're doing. You can find, well, first of all, be sure to join us at .NET Conf when we will be announcing the stable release of all these great features, November 11th through 13th. It's going to be an awesome event. You can find more details about all these features and how you can get started with .NET 10 at get.net/10, and then check out our What's New documentation roadmap for more details on all the features that you just seen. And yeah, that's what I had to show for you today.